So now that we have all the probabilities, the marginal probability and all the conditional probabilities, we are now ready to do the computations for naive classification. Suppose if this is the new predictor profile for a new flight. So we have delta, day of the week, departure time, and destination, origin, and weather. So we need to get the conditional probability for each of those predictor values. So if it was exact base, then we have to look at this particular predictor profile all joined together. But that would be almost impossible. So we're going to look at each of them individually. So the first one is DL, so which is that. Okay. All right, next one is day of the week is 7. So next one is day of the week is that, right? Departure time is 10 to 10:59. That will be that. Destination is LGA. Origin is DCA. And weather is 0. Okay. So these are the conditional probabilities, and joint probability is the product of all this, okay, and of course the marginal probability too. So we need the marginal probability. Well, let's go ahead and insert a new row here. So the marginal probability. So we'll bring the marginal probability also down here. So marginal probability is that. Okay. So the formula, okay, so remember from our previous example. Okay. So the naive, the formula is the marginal probability and then all the conditional probabilities. The previous example we had only 2 predictors, so we had only 2 conditional probabilities. Now we have several. So we have to multiply all of them together like that. Okay, so which in this case that would be the joint probability. So we can use the product function and all of that. Okay. So marginal probability times the first conditional probability times the second conditional probability for the second predictor, and so on. Okay, so let's increase the okay. So do the same thing here. All right. So now when you sum these 2 probabilities, that will give us the probability of that is an estimate of the joint probability for that particular predictor profile. Now you divide that into each of them. So you take that and divide by that and make sure that you absolute reference that. Okay, so here let's see. So this is the propensity for delay. That is propensity for on time. Okay, based on naive Bayes classifier. Okay. Now whatever may be the flight profile, okay, a new flight, okay, with these predictor variables, you can get the probabilities from these tables and we can compute the propensity for the event of the target variable. Okay. Propensity for delayed is 0.058 and propensity for on time is 0.9420 for this predictor profile.